Sanskar, till the time we have seen that if sound is below 20 hertz, it is called ultrasonic, and if it is above 20 kilohertz, it is called ultrasonic sound. So, in this segment we are talking about ultrasound. Ultrasound is very high frequency wave. Ultrasounds are able to travel along the well defined path even in presence of obstacles. Ultrasound are used extensively in industries for medical purposes. For example, ultrasound is generally used to clean part located into hard to reach places. For example, spiral tube, spiral આવી રીતની ટ્યુબ્સ હોય ને એની અંદર જવું બહુ ડિફિકલ્ટ હોય. Odd shaped part, electronic components, object to be cleaned are placed in cleaning solution and ultrasonic waves are sent into the solution. Due to high frequency, the particles of dust, grease, dirt get detached and drop out. The object thus get thoroughly cleaned. Ultrasound can be used to detect crack and flaws in metal blocks. Metallic compounds are generally used in the construction of big structure like buildings, bridges, machines, also scientific equipment. Cracks or holes inside metal blocks which are invisible from outside reduces the strength of structure. Ultrasonic waves are allowed to pass through metal blocks and detectors are used to detect the transmitted wave. If there is even a small defect, the ultrasound gets reflected back and deciding the presence of flow or defect as shown in figure. So, basically if we want to clean this kind of spiral tube, what they do, they enter the waves into it, and with the help of this wave, because of push of this wave also do carry energy, and the whatever dust particle would be come out. Another thing is, if I have a metal block, something like that, then ultrasound will pass through it. But if there is a tiny, suppose there is a hole or there is a hollow space between them, then what happens? These light ultrasonic sound will reflect and get back, and with help of this we can know this metal block has a defect into it, so it can not be used in something like a tower or a bridge or building, multi-story buildings. Ordinary sound of longer wavelength cannot be used for such a purpose. It is well as it will bend around the corner and defective location and enter to the detector. Ultrasonic waves are made to reflect from various parts of heart and from image of heart. This technique is called echocardiography. એકો કરાવવાનું તમે સાંભળ્યું હશે, ઓલ્ડ એજ પર્સનને હાર્ટનું એકો કરાવ્યું કે એકોકાર્ડિયોલોજી કરાવી. સો બેઝિકલી હાર્ટની અંદર આ સાઉન્ડ જે છે એ પાસ થાય અને જ્યાંથી ઓબ્સ્ટિકલ્સ હોય ત્યાંથી એ બેક જતું રહે, મતલબ ખબર પડે કે આ ક્યાં, તમે સાંભળ્યું હશે આટલી નળી બ્લોક છે હાર્ટની અંદર એવું કહેતા કોઈને. સો દેટ ઇઝ અ રિપોર્ટ ઓફ એકો, એન્ડ અલ્ટ્રાસોનિક સાઉન્ડ ઇઝ યુઝડ ઇન ટુ ઇટ. Ultrasound scanner is an instrument which is ultrasonic waves for which uses ultrasonic wave for getting images of internal organ of human body. A doctor may image a patient's organs such as liver, gallbladder, uterus, kidney, etc. It helps the doctor to detect abnormalities such as stone in the gallbladder, kidney or tumors in different organs. In this technique, ultrasonic wave travel through the tissue of the body and get reflected from region where there is a change of tissue density. These waves are then converted into electronic signal and then it is used to generate image of an organ. These images are then displayed on a monitor or printed on a film. This technique is called ultrasonography. Ultrasonography is also used for examination of fetus during pregnancy and to detect congenital defects and growth abnormality. જ્યારે કોઈ બેબી મધરના વોર્મની અંદર મોટું થતું હોય ત્યારે એની અંદર જો સાથે સાથે કોઈ એબનોર્માલિટી ગ્રો થઈ રહી છે ઓર એ બેઝિકલી પ્રોપરલી ડેવલપ નથી થઈ રહ્યું, તો આ વસ્તુ પણ ચેક થઈ જાય સોનોગ્રાફીની હેલ્પથી, અલ્ટ્રાસોનિક સાઉન્ડના હેલ્પથી. Ultrasound may be employed to break small stones formed in kidney into fine grains. These grains later get flushed out with urine. બ્લડ ની અંદર જો બેઝિકલી કિડનીનું કામ છે બ્લડને ફિલ્ટર કરવાનું, અને એની અંદર જો કોઈ એવા ગ્રેન્સ બની ગયા, સ્ટોન્સ બની ગયા બોડીની અંદર, તો એને ડિટેક્ટ કરી અલ્ટ્રાસાઉન્ડ વેવનો આપણે યુઝ કરી, અલ્ટ્રાસોનિક સાઉન્ડ વેવ્સનો, અને આપણે એને આપણા બોડીમાંથી એને કટ કરી શકીએ, સ્મોલર પીસીસની અંદર કટ થઈ જાય, ધેન ઇટ ગેટ્સ આઉટ ઓફ ફિલ્ટ્રેટ એન્ડ ધેન ઇટ પાસીસ થ્રુ urinary passage. Okay, so it doesn't stay inside your body, it just cut them apart. We are able to cut it with the help of sound. Next is sonar. Acronym sonar stands for sound navigation and ranging. Sonar is a device that uses ultrasonic waves to measure the distance, directions and speed of underwater object. How does the sonar works? Sonar consists of transmitters and detectors is installed in the boat or a sea. The transmitters transmits ultrasonic waves. These waves travel through water, and after striking the object on the seabed, they get reflected back and are sensed by the detectors. The detectors convert ultrasonic waves into electrical signal, which are appropriately interpreted. This distance of an object that reflects the sound wave can be calculated by knowing the speed of sound in water and time interval between transmission and reception of the sound. Let the time interval between transmission and reception of ultrasound to be t and velocity of sound to be v. The total distance would be 2d. 2d is equal to v multiplied by t. The above method is called eco-ranging. Sonar technique is used to determine the depth of sea and to locate underwater hills, valley submarine, icebergs, sunken ships, etc. હું જ્યારે નાની હતી ત્યારે મને એવો પ્રશ્ન બહુ થતો કે સી કેટલું ઊંડું છે, એ તળિયાને જઈને અડીએ નહીં ત્યાં સુધી કેમ ખબર પડે? બટ દેર આર સોનાર, અહીંયા ડિટેક્ટર હોય શિપના બેઝના ભાગની અંદર, અને અંદરથી ટ્રાન્સમીટર્સ થ્રુ સિગ્નલ્સ મોકલે અર્થની અંદર. એ તળિયા સાથે કે કોઈ ડૂબેલા જહાજ હોય તો એની સાથે ભટકાય અને પાછા આવે, એટલે ખબર પડે કે અહીંયા કંઈક ડૂબેલું જહાજ છે, કે અહીંયા કંઈક ડેડ બોડી છે, કે અહીંયા કાંઈ પણ વસ્તુ છે, કે તળિયું છે, હે ને. સો એક વખત ડિટેક્ટ થઈ જાય પછી ત્યાંથી ઇન્ફોર્મેશન જે છે પછી ત્યાં ડાઇવ કરીને નીચે જઈને જોઈ શકે, પણ બેઝિક થિંગ એ છે કે ખબર હોવી જોઈએ કેટલું ઊંડું છે. Okay, next example is a ship sends out ultrasound that returns from seabed is detected after. Okay, time is example 12.3. Okay, time is 3.42 seconds. If the speed of ultrasound through seawater, so velocity is equal to 1531 meter per second. What is the distance of seabed from the sea? So velocity is what? Distance divided by time. But this is 2 times the distance, okay? Because once it is going over there, then coming back. So velocity, therefore, distance, 2 times distance would be equal to 1531 multiplied by time, 342 divided by 100, this many seconds. So you are just supposed to multiply these two and then you will get the answer, and then you are supposed to divide it by, this whole thing should be divided by 2, and then we will get the distance. So that would be the distance travelled by this sound, or the distance of seabed from the ship. Okay. As mentioned earlier, bats search out prey and fly in dark night by emitting and detecting reflection of ultrasonic waves. The high-pitched ultrasonic squeaks of bat are reflected from the obstacle and prey and return to bat's ear. The nature of reflection tells a bat where obstacles of prey is and what is it like. Porpoises also use ultrasound for navigation and location of food in the dark. So these are used by these things. Even some certain modes also use. So basically transmitter or wave generator are wings of bats. Okay, bats has very complicated structure. How can I draw something like this? So this kind of structure is there of bat. So in these wings you will observe that there is with this frequency they generate wave. These waves are ultrasonic. Okay, and then whatever sound which is it is going and then it is coming back. So sound is detected by ears of bat. Okay, so this is how they do find their prey, and this is how they do fly in dark place or caves where they do survive. Okay, and that's all for now. Thank you.